Hey, stats students, we're getting ready today to put some closure on chapter 4. Today we're going to take a look at these notes from our friends at Stats Medic. Does caffeine increase heart rate? This is the finale. So it says today we'll be testing to see if caffeine increases heart rate. Begin by taking your heart rate. Okay, you would fill this in. We're not actually going to do that part of it. So we won't be able to answer all the questions on here because they're relative to our experiment. But we are going to be able to answer several of them, especially those that deal with Mrs. Gallus's class, because we've already been working with that in previous lessons. Mrs. Gallus took a random sample of 5 students' heart rates. The sample mean was 64.5 beats per minute with a margin of error of 5.6 beats. Can she expect that the sample mean is the same as the population mean? Well, no, you can't expect it. It's possible. It's highly unlikely that it's going to match the population mean exactly. I mean, ideally, we would like it to, but the fact of the matter is when you select a sample, you're probably going to have a slightly different mean. Number 3, would you be surprised to learn that the true population mean was 68 beats per minute? Well, let's see. We got 64.5 beats per minute, and she said that her margin of error was 5.6 beats. So if we take the 5.6 beats, subtract from 64.5 and add to 64.5, we find our range that we would consider plausible. So if our mean is between 58.9 and 70.1, that's plausible. In this case, 68, yeah, that fits within our margin of error. So we would not be at all surprised that the actual mean was 68 based on our information. Question number 4, how could Mrs. Gallus find a sample mean that is close to the true population? Well, one suggestion mean would be she could increase the sample size. She only took a sample of 5 students. I mean, you could do a larger sample than that and see what you get. And remember, the larger the sample, generally the more accurate your mean is going to be. Not necessarily the case because everything's randomly selected. However, it is much more likely in statistics that if you increase the size of the sample, you also increase your accuracy for the mean. Question number 5, Mrs. Gallus will give you a beverage to drink. Okay, you're going to drink the entire beverage. It is an observational, or is this an observational study or an experiment? Well, clearly this is an experiment because a treatment's being imposed. She's giving you something to drink. If it's an observational study, then you don't have treatments for observational studies. You just make an observation. Number 6, was blinding used in the experiment? Yeah, absolutely it was. She didn't tell you what kind of drink you're going to have. You might have the caffeine, you might have the non-caffeine, but the reason why we use blinding is to reduce the placebo effect. Number 7, describe what a confounding variable is and list a few that might occur and affect our results in this situation. A variable that has some degree of influence on our results, which may not have been controlled, is called a confounding variable. Some examples that could have happened in this case is we don't know what the subject had to eat or drink that day or prior to class. Maybe they already had some caffeine. That we didn't have control of that. So maybe they didn't. Maybe they had a lot of exercise that day, so their heart rate might be faster. It's a lot of different things that could happen. Also, a subject's tolerance to caffeine. Maybe somebody that drinks caffeine constantly isn't going to be affected by whatever dosage that Mrs. Gallus gives them. The time of the day might have an effect too. Did the student just roll out of bed in the morning, or have they been up and around and going for a while? Those are all confounding factors that could affect our results that we really can't control. So we just have to live with that as part of our survey and experiment. So number 8, if we really want to see if caffeine increases heart rate, why can't we just have one group who all drinks caffeinated Coke? Well, we would not have a control group then. You can't have everybody take the same treatment and call it an experiment. You have to have at least 2 treatments so you can make a comparison. So that was the end of the first page of notes for this closure on chapter 4. Number 9, identify each of the following. The explanatory variable in our case would be the caffeine. The response variable is a change in pulse rate. So we're going to give them caffeine or not, and we're going to check their change in pulse rate. That's explanatory, and that's the response. So your experimental units in this case would be students. So they'd be called subjects. The treatments that we have are they ingested Coke with caffeine or they ingested Coke without caffeine. They drank Coke no matter what. One of them was decaffeinated and one was caffeinated. Number 10, describe how we could randomly assign the students in the class into 2 groups. Okay, there's different ways to do it, but here's the one that I chose for you guys. How about if we associate a number from 1 to 30 to each student? Then we use a random number generator to choose a group of 15 students to be assigned for treatment A. The rest of the 15 students will be assigned to treatment B. And that's one way that we could do it. Why do we use random assignment to create 2 groups? What is its purpose? Well, the reason why we use random assignment is to hopefully create roughly equivalent groups before we impose the treatment. Number 12, draw an outline. So here's my outline for you. Start with 30 students. You randomly assign them to 1 of 2 groups. So you got your group 1, and that's 15, your group 2 of 15. Then you got your treatment 1, which is give them the caffeine. Treatment 2, don't give them the caffeine. Give them the non-caffeinated. And then you compare your results at the end. That's a drawn outline. Okay, so 13 is going to talk about some vocabulary words for us. What are the 4 key principles of experimental design? Explain how your experimental design in number 12 meets all of them. So in the previous design, how does it meet all 12? Or how does it meet all of these? So you start with control. You've got random assignment, you got comparison, you got replication. Okay, let's relate that to 12. Let's go back. Here it is. There's your experiment in 12. All right, so how do we do the control? Well, we kept other variables consistent. For example, the amount of soda, the temperature, everything's going to be consistent to the best that we can. We're trying to eliminate as many confounding factors as possible. Number 2, the random assignment that we used, we chose a random number generator to select the 15. We didn't just do it by convenience, we did it by randomness. So number 3, we did a comparison. We'd have 2 treatments to compare. And then number 4 is replication. We considered 30 subjects. I'd say 30 subjects, probably enough. I mean, if you only had like 3 or something, probably not. You don't have enough replication. But 30, it's considered to be a good amount for statistics. All right, so number 14, Mrs. Gallus thinks that gender may play a role in the effect that caffeine has on heart rate. Maybe it does. How could we adjust our experiment design to account for this? Well, then we would do a blocking. We'd block by gender. So to do this, we'd separate the students into groups by gender. So you'd have your males and your females. Then you'd separate each of the 2 groups, 1 for each treatment. So you're going to have 4 groups overall. So here's a picture of it down here. This is your outline. Start with your 30 students. You block them into male and female, and you don't worry that it's not an equal amount. It's not exactly equal, but we're going to make it equal by taking half of this and half of this. So we have half of the males are in group 1. Now this would be a random assignment as well, guys. Make sure you select them randomly. The other half, or 8 of them, are in group 2. For group 1, you give them the caffeine. For group 2, you don't. For the same for the females, group 1 is going to have the caffeine. Now, there'll only be 7 here and 7 here, but that's okay. Statistically, we're doing the best that we can with the data we have. So you've got the first group gets caffeine, the second group, no caffeine. Then what you do is initially compare the males with caffeine to non-caffeine. You'd compare the females to the caffeine to the non-caffeine. And then at the end, you'd compare both groups together. So hopefully you're getting this okay. Please feel free to stop the video and repeat it, or send me an email or a text and let me know, and we'll help you out. So number 16, could we use a matched pairs design to test the effects of caffeine? If yes, describe the process of pairings. If no, explain why not. Well, absolutely, we could use a matched pairs design. What you could do if you wanted to, what I put down your notes for you is you check the heart rates of all the students, and then you take the two with the lowest. So you list them from lowest to highest heart rate. Take the two with the lowest, you put them together, and then you flip a coin. One is going to be split into a group that is going to take the caffeine, and one's going to be split into the group that's not going to take it. Then you look at the next two lowest. So you got two students, flip a coin, one goes into each group. Then you take the next lowest, and eventually you get to the two highest. And then you flip a coin, and one of them goes into one of the groups, and one of them goes into the other group for treatments. So you repeat the pair and split process until all the subjects are placed into the group. So then you'd have your two groups. One is going to be a caffeine, one is going to be a non-caffeine, and you'd still want to use a blind test for that. Now, when it gets to 17 and 18 and 19 and 20, my friends, that they want us to do this ourselves in class, and we're not in class right now. We're on virtual learning, so that is something we would have to do when you come back, or maybe next year. Okay, so last page. Can we generalize the results if we had done this experiment? Okay, so let's think about Mrs. Gallus's class. For Mrs. Gallus's class, could we generalize the results? If you used a random sample, you could, but it's not a random sample. It's a convenient sample. When you select all the students in your class to participate, that's a convenient sample. That doesn't necessarily represent the population. Can we determine cause and effect? Yeah, we could use random assignment within our class, which means that we randomly assigned people in our class, and we could determine if there was cause and effect. We could determine if it was statistically significant that the caffeine caused heart rates to rise. Conclusions, that would depend on whatever data we had. This one talks about that ethical stuff. The ethical stuff is not on the AP test, but it's at the end of the chapter. Was this experiment conducted in an ethical manner? Well, we'd have to say no, because we don't know that she went through that instructional review that they described in your book. Now, she probably fulfilled the rest of the conditions of ethical manner of conducting a survey. She probably told the students ahead of time what the experiment was about, what was going to happen, and how the results were going to be utilized. And she probably also did not contain any individual information of any of the individual students' heart rates. She probably just put them together for the total. At least that's what it looks like. So anyway, that concludes this review at the end of chapter 4. Once again, I want to thank our friends at Stats Medic. You guys are awesome. Keep providing us good videos. And so I'm going to sign off here from Oshkosh North High School. It's your math teacher, Mr. Murphy, wishing you a great day. And remember, stay awesome, Spartans.